Way 55 tells you how to take a molecular formula and convert it to an empirical formula. The way we do that is we take the molecular formula and we take the subscripts of each element and we divide by the greatest common factor within the ratios of those elements. And the way we do this is we try to find the greatest common factor within a set of numbers and divide every single number by that value in order to convert to the empirical formula. Now, please note that the molecular formula tells you the actual values of atoms present within a particular structure. The empirical formula merely tells you the ratio, the smallest positive integer ratio of those elements relative to each other. So let's try some problems that deal with this idea. Which formula is an empirical formula? The key difference between a molecular and empirical formula is that you can no longer reduce an empirical formula. So for example, notice that the ratio of choice 1 is 2 to 4. Well, 2 is a common factor of 2 and 4, and we could reduce this to N1O2 if we divide that number by 2. Notice answer choice 2 cannot be reduced in such a way because there's no greatest common factor of 1 and 3 other than 1 itself. Notice that the ratio of 3 to 6 can be reduced from 1 to 2, and so can this. The greatest common factor of 4 is 2. We can reduce this if it were a fraction of 4 to 10 to 2 to 5. So when you think of the empirical formula, think of the subscripts as a ratio or a fraction and see if that fraction can be reduced. If it can't be reduced, it's an empirical formula. If it can be, it's a molecular formula. Which molecular formula is also an empirical formula? Now, sometimes there are molecular formulas that can no longer be reduced by themselves. And if the molecular and empirical formula are the same, then that means that the molecular formula is irreducible. Notice that choices 1, 2, and 3 all can be divided by some common factor between the two subscripts. 6 to 6 can be divided by 6, 2 over 2 could be divided by 2, and 2 to 4 could be divided by 2. But the only answer choice that cannot be reduced is choice 4. Therefore, N2O5 is a molecular formula as well as an empirical formula. What is the empirical formula for C6H12? We can take the molecular formula and reduce it by 6. Dividing 6 by 6 will take you to 1, and dividing 12 by 6 will take you to 2. So the empirical formula is simply CH2. In 1828, Frederick Wohler produced urea when he heated a solution of ammonium cyanate. This reaction is represented by the balanced equation below. Here we have ammonium cyanate converting to urea. Write an empirical formula for the product. Please note that the products are on the right side of the arrow, the reactants are on the left. So we're trying to find the empirical formula of the product. To do so, we need to first convert this to a molecular formula. All we have to do that is simply count the number of each atom present within the structural formula. There's 1 C, 1 O, 2 N's, and 4 H's. But notice that when we write down this molecular formula, this can no longer be reduced by any more than it already is because of the 1 carbon present and the 1 oxygen present within this formula. So this molecular formula just happens to be the empirical formula as well. The formula C2H4 can be classified as Because the proportion of C to H is 2 to 4, and it can be reduced to 1 to 2, it couldn't be an empirical formula. Therefore, the only answer that makes sense is choice 1. Given the formula for a compound, which molecular formula and empirical formula represent this compound? Here we're provided with a structural formula. We have to count all the atoms present in order to identify its molecular formula. Count the number of C's, O's, N's, and H's present, and we see that the number of C's is 4, number of H's is 2, number of N's is 2, and the number of O's is 4. So we can eliminate choices 1 and 2 as possibilities. So it's between 3 and 4. Note that 3 and 4 list the molecular formula. To convert to the empirical formula, we have to divide by the greatest common factor. Well, notice that all these numbers can be divided by a 2. Therefore, the answer is choice 4. The equation below represents the reaction between 1-butene and bromine to form the compound 1,2-dibromobutane. Write the empirical formula for the product. Again, we're provided a structural formula. We need to get its molecular formula. Count the atoms. There are 4 C's, there are 8 H's, and there are 2 Br's. If this is the molecular formula, to reduce it to its empirical formula, divide by the greatest common factor, which happens to be 2. When we do that, our empirical formula turns out to be C2H4Br. Note that I didn't write a 1 here because there's already a 1 Br present by virtue of writing its symbol. Okay, so when it comes to molecular formulas, to convert to empirical formulas, simply divide by the greatest common factor. Sometimes these formulas are the same if the molecular formula can no longer be reduced, if the proportion of atoms can no longer be reduced. And that would make the empirical and molecular formula the same. Thank you for watching.